Good day, dear conference participants. I want to present our work on the topic Comparative Analysis of Ensemble Methods for Outlier Detection in Real Estate. Numerous studies in the field of machine learning show how two approaches suddenly dominated: deep learning and ensemble learning. Deep learning is known for its ability to automatically extract useful patterns from new data, such as images or audio. Ensemble learning, in turn, has shown high efficiency in building models of structures that already contain meaningful features. It imitated the natural human habit of referring to several opinions before making an important decision. The basic principle of ensemble learning is to weight the results of individual models and combine them to achieve a more accurate answer than the one that a single model could obtain. Outlier detection is the key technique in building effective machine learning models for real estate valuation. The accuracy of such models is directly related to the quality of the data. It is important for investors, sellers, and buyers that the price of the object not accurately reflects the current market situation. The non-standard nature of outliers often significantly worsens the forecasting results. Therefore, there are many used algorithms that detect outliers based on various criteria: distance, destiny, angel, etc. More modern approaches involve the use of ensemble machine learning methods for such tasks. They allow to increase the accuracy of outlier detection. The purpose of our study is to analyze the effectiveness of ensemble machine learning methods for detecting outliers in real estate data, as well as to develop an optimized approach that combines the advantages of different algorithms to increase the accuracy and stability of detection. This will create a theoretical and practical basis for automating data cleaning in real estate data processing systems. As part of this study, the city of Ternopil was selected for the analysis of real estate information. To obtain and maintain the relevance of the dataset, developed software was used in the form of a Windows application, a Microsoft SQL Server database, and a website. Data collection was carried out by parsing the internet pages of real estate portals popular in the region. The study used data that was in the database as of the beginning of 2025. The dataset contained description of 760 offers for the sale of apartments and rooms in dormitories in the city of Ternopil. To form a dataset that was subsequently used for machine learning, the software was supplemented with a function to export the necessary fields to CSV format. In total, 14 columns were exported from the program. The first column is the object ID. The next 12 columns are features describing the real estate object. The last column is the anomaly label. The anomaly label on each real estate object in the dataset was extended by expert based on analysis of the object's location, its characteristics, and cost at the stage of adding the object to the database or changing its price or condition. For this purpose, a set of rules was created that allowed detecting anomalous values that significantly differ from the average indicators for the region. For example, objects with too low or high cost compared to other objects of a similar type and location were considered potential anomalies. Analysis took into account that the piece of one SQM of housing is usually higher for the small apartments, mainly one-room ones. In addition, typical combination of characteristics taken into account, such as the high cost of apartments in older buildings, mainly from the 18th and earlier. The dataset prepared in this way contained 10% of the observed anomalous objects. The effectiveness of ensemble methods from outlier detection was tested in Python. Data processing was performed using pandas, numpy, sklearn, and paired libraries, and visualization was performed using the matplotlib library. The list of studied ensemble algorithms and their characteristics are given in the table on the left. All of the mentioned algorithms are components of the Python outlier detection library. By default, future bagging uses the LOF algorithm as a base estimator. We extended the future bagging study by using the CBLOF, KDE, KNN, OCS-VM, and QMSD algorithms as base detectors instead of LOF. These algorithms showed the best individual results in loud outlier detection of the studied dataset. The test results indicate that the way categorical features are encoded and data scaling affects the accuracy of each ensemble differently. We have summarized these results and propose metrics for selecting the optimal characteristics of the dataset for each ensemble algorithm. The metric is presented in the lower left corner of the slide. Let us explain it using the example of the iForest algorithm. The best result is achieved when using the label encoder, which the data scaling does not play a role. For a more comprehensive evaluation, each algorithm was tested on a dataset that had undergone different processing methods for encoding categorical features, label encoding and one-hot encoding, as well as with and without data scaling. The results of the work were evaluated by three indicators: area under the curve, received operating characteristics, precision, algorithm execution time. 100 experiments were conducted for each combination of algorithm and dataset. The metrics were averaged. Among the considered algorithms, the following ensembles have the best accuracy indicators: INNA, LLDA, feature bagging plus SBLOF, feature bagging plus KNN. Also, the FB plus QMCD ensemble showed high results. We included it from future research due to the fact that the spread of metrics in the experiments was quite significant. The next step of the study was to optimize the hyperparameters of the selected ensemble in order to obtain the best result that each ensemble algorithm can provide. In our study, the Optima framework was used. This is an open source library that provides efficient optimization by applying modern hyperparameter selection algorithms in effective running and promising trials. The AOS-ROS metric was chosen as the objective function for optimization. The goal of the optimization was to maximize the value of the objective function. Hyperparameter search space was specified individually for each ensemble or base algorithm. The result of hyperparameter optimization for each ensemble are presented in tables. The next two slides present the visualization of the optimized outlier detection algorithms using PCA and TSNE dimensionally reduction methods. The visual assessment demonstrated the high accuracy of anomaly detection by each algorithm. These figures show respectively generalized diagrams of the AOS, ROC, and PN metrics of the studied algorithms when detecting anomalies with default settings and after hyperparameter optimization. Optimization on the settings provides an increase in the AOC, ROC, and PN metrics. At the same time, the variable dispersion of the forecast decreased and the number of outlier forecasts decreased. The conducted comparative study showed high accuracy of ensemble machine learning algorithms in outlier detection tasks in real estate data. The best among all the options considered is a combination of the future bagging method and the optimized basic detector CBLOF. At the same time, height metrics and optimal running time are provided. Slightly lower but quite close indicators are given by the combination of the feature bagging method in a pair with the optimized basic detector KNN, but this pair works faster than its predecessor. The optimized ENNA algorithm is also not much inferior in metrics but is the slowest. Regarding the LODA algorithm, for which hyperparameter optimization was also performed at the highest metric indicator in the lowest. This is visually confirmed by its graphs, which shows that the operation of objects and normal and abnormal is less clearly expensed in comparison with other described algorithms. Further research of the topic of this work can be aimed at analyzing the effectiveness of other ensemble techniques and algorithms for outlier detection, including the combination and hyperparameter optimization. Thank you for your attention.